Okay, ladies and gentlemen, let's start talking about solving equations using addition and subtraction. Now, the first thing we need to talk about is the difference between an equation and an expression. X plus 2 is an expression versus x plus 2 equals 4 is an equation. Because an equation has an equal sign in it. That equal sign tells you it's an equation, not simply an expression. Now, in an expression, we can put a number in and say, what if x equals 7? I could say 7 plus 2. There we go. And 7 plus 2 is 9. However, if I say x equals 7 down here and I say 7 plus 2 equals 4, 9 equals 4, that's not true. In an equation, the x can only have a single value. So in this case, we're not looking at necessarily plugging numbers in to evaluate. With equations, we wish to solve. So we're going to learn to solve equations using addition and subtraction. Okay, now ladies and gentlemen, for solving equations using addition and subtraction, we actually have three methods we can use. One is the bar method. The bar method is, you draw, shockingly enough, a bar. And that bar is going to be all 10 units long because x plus 7 equals 10. Now, since 7 is smaller than 10, we would say, here's 7 of them right through here. That's 7. So the question is, 7 plus what equals 10? And so hopefully at this point you say, wait a minute, 7 plus how many more is 10? X equals 3. So 3 would be the solution. Alternatively, what we can say over here is we can say x plus 1, 2, 3, 4, 5, 6, 7 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, obviously, we're not going to use either the bar or the tile method very much because how long would your bar have to be? Well, you don't know, and so it's just a picture organizer, and it has limited use. The tile method, the problem is, what if I had 7x plus 72 equals 105? I certainly wouldn't want to draw enough tiles for all that. But in this case, we can pretty well easily see that 10 take away 7 is 3. On the other hand, if I have 10 of these little blocks, over here I only have 1, 2, 3, 4, 5, 6, 7. Could I cancel one off each side? Until I have the number remaining, and it clearly shows me in the tiles that x has to equal 3 because I only have 3 blocks left. So that's all fine and dandy, but what we're really headed for was algebra. And algebra is simply using letters as variables, letters as placeholders in equations and expressions. Now, in this case, algebra, our x is our letter, plus 7 equals 10. Well, over here, I got rid of 7 off this side and 7 off this side. The way to think about algebra is to think about a scale. And whatever I do to one side, if I put one block in over here, I best put one block in over here, otherwise things don't stay equal. If I put 4 things over here, the scale is going to tip unless I put a whole 4 things over here. So the key here is called balance. And that's why we call it balancing equations. Now in this case, I want to get x by itself. The way to get rid of a plus 7 is to reverse it. Well, the reverse of plus 7 is going to be minus 7. But I can't just do it to one side. That would make the balance beam go off. What I need to do is if I take 7 off one side, I must take 7 off the other. And in this case, I have 7 minus 7 is 0. And so all that's left on this side is an x equals 10 minus 7 is 3. So I come up with 3 over there. So I have bar method, tile method, algebra method. Those are your 3 methods. And I'm going to get x equals 3. Here's what I want you to do. I want you to take a look at a couple more examples. Example number 1, if we have x minus 7 equals 13. Example number 2, if I have 4 plus x equals 3. If I have example number 3, I have negative 2 plus x equals 5. And over here for example number 4, I have 5 plus x equals negative 3. So, we're going to go with these problems right here, right now. I want you to see what you can do with them. Okay. Now, in this case, I need to get rid of a minus 7. So the opposite of minus 7 is plus 7. And I'm going to do it to both sides. X equals, well, these two go away. 13 plus 7 is 20. Over here, I'm going to have 4 plus x equals 3. To get rid of that, I'm going to say, well, wait a minute, how do I get rid of a positive 4? Because see, the kicker is there's a secret positive there, positive 4. I would subtract it. But if I do it to one side, I must do it to the other. These go away. X equals now 3 take away 4 is actually going to give me a negative number. It's going to be negative 1. Over here, how do I get rid of a negative 2? The opposite of negative 2 is positive 2. And so if I put a positive 2 on this side, I must put a positive 2 on this side. These two go away. X is the only thing that's left over here, equals 5 plus 2 is 7. Finally, we're back to one of those secret pluses because this plus goes with the x. What's in front of this 5? A positive. The way to get rid of a positive, minus. It's a negative. So minus 5 on this side, minus 5 on this side. Those go away, leaving x. But here's the thing. What is negative 3 and negative 5? Now remember, we're adding, not multiplying. So the negatives don't go away. I owe $3. I owe $5. So I owe a total of $8. So there's your answers for these. You can double check them. In the meantime, we're going to have some quizzes that you need to do. See what you can come up with.